Hey guys, welcome to Mathletics. Today I'm going to talk about substitution methods to solve first order differential equations. Like every substitution in math, this too will make it easier for us to solve some type of differential equations. Let's talk about homogeneous equations. Now, what do you mean by homogeneous? A function, say p of x and y, is homogeneous of degree t if p of alpha x and alpha y is equal to alpha t p x y. Now, I know this looks insane, but let me show you with an example what this means. So suppose you have this function. Then if I substitute every x and y with alpha x and alpha y, then I get 4 alpha x minus 2 alpha y. So if I take alpha out of both of these, I get alpha times 4x minus 2y. Now it just means that each term has an equal number of the total number of x and y. So the total number of x and y in the first term is 1, and the total number of x and y in the second term is 1. How will this help us to solve differential equations? Let's see. First order of business is we will introduce a variable v to help us do a substitution. And we will call it v is equal to y divided by x. Now, I want you to keep in mind that here y is a function of x. X is x, so v is a function of x. So if I move x here, I get y is equal to vx. Now if I take the derivative dy over dx, I'll have to use the product rule here. And what I get is v plus x times dv over dx. So now say you have a first order differential equation. That's what we're dealing with right now. And it looks like dy over dx is equal to f of x and y. It's just a function. And if f of x and y is homogeneous, then we will make a substitution for all the y's that appear in this function. Let me show you what I'm saying with an example. Say dy over dx is equal to xy divided by x squared minus y squared. Now we should check first if this is homogeneous. So this is our p of x and y. So if we write it again, then I will substitute, as I said above, alpha x and alpha y for all x and y. I will get alpha squared xy over alpha squared x squared minus alpha squared y squared. Now, I can take alpha squared out of each of these terms. So we can see that this function is homogeneous of degree 2. All terms have the same total of x and y, which means the first term, total number of x and y is 2. 2 here, 2 here. By total number, I mean this is x times x, so that is 2. This is y times y, that is 2. This is x times y, that is 2. Okay, so we've checked that this is homogeneous. So for our substitution, we have y is equal to vx. So dy over dx is this, as we've said above. Now I'm going to substitute this for this. Then I have and here I'm going to substitute Vx for every y. Then I get then this is equal to Vx squared divided by x squared minus v squared x squared. Now I can cross out all of these. Then I have left v plus x dv over dx is equal to v over 1 minus v squared. Now I'm going to move this v here. Then I have x dv over dx is equal to v divided by 1 minus v squared minus v. To simplify this, I'm going to divide this by 1 minus v squared and multiply by 1 minus v squared. If you do a little bit of algebra, you should end up with x dv over dx is equal to v cubed over 1 minus v squared. Now, we are going to separate variables. This is a separable equation. You guys don't know what that is? Check out my video on separable differential equations. So all of this, I'm going to move here. And all of this, I'm going to move here. So I get is equal to 1 over x dx. You guessed it, we are going to integrate both sides. And I will first simplify this and write it as v to the power negative 3 minus 1 over v dv which is this. And this is just ln x. We equate and add a constant. Last step, you substitute this again, but this time you will substitute all v's for y over x. So we are back to our variables that we were using, that the question asked. Then you get now you could go ahead and solve for y, but that's going to be very tedious and complex and unnecessary. This is a very much acceptable answer for that question. So I hope that made sense. Now I'm going to give you guys a shortcut. To solving homogeneous differential equations. You check if p of x and y is homogeneous. Substitute all y's for this. Substitute dy over dx for v plus x dv over dx for separate variables. 5, you integrate both sides. And lastly, you substitute all v's for y over x. Here's the shortcut. You can take a screenshot, put it on your notebook, whatever helps you. So this was my video on using substitution methods for homogeneous first order differential equations. If this helped you, do share it with your friends and like the video and subscribe to my channel for more videos. And I'll see you guys very soon.